Alright, so here we go. Another video. This one's going to be over literal equations. So be ready for this. What do I want you to do with this one? I want you to use properties of equality to solve equations for an indicated variable. So anyways, what is a literal equation? Let's understand this. Equations with multiple variables, usually you're just trying to solve for a specific variable. So realize you're not going to get a numerical answer here. And you're just going to try to be using what you should know, like what you do with numbers. Treat these variables like if they were numbers. Anyways, let's look at the first example. Probably the most important example. So we have 3x plus 2y equals 16. Okay, here's like what we think of as a normal, what would be the word? Slope-intercept form of an equation, normal linear equation. Okay, so how do we solve this? Well, we go about solving this like if we want to solve for y, let's say, because that's usually how this works, then, you got to treat like, say, the 3x. 3x is being added to 2y. Well, since it's being added, you can treat it like, well, what do we do? We normally add, subtract, multiply, and then try to divide. Well, let's go ahead and subtract the 3x. So we're moving this 3x over here. Okay. Now, when we try to move it over and say 16 minus 3x, we can't actually do that. So we just write, negative 3x plus 16, or you could have written 16 minus 3x. Then I need to divide, because I want y by itself, so that 2 times y needs to be divided. So I divide everything by 2, and then I get my answer. Okay? This one, you're going to see a lot, because this is what is known as standard form of a linear equation, and the form we have now is in slope-intercept. So we're going to see that one a lot, so you need to make sure you understand that one. But let's try some other ones that are a little bit more difficult. Okay, this one I got straight from the book. Slow down. Okay, so let's look at this. Here we have the area formula for a trapezoid. Oh no, not geometry, sir. Don't bring geometry back. Anyways, so the idea is, what can I do? Well, let's see here. Let's take things one step at a time. It says that it's 1/2 times h times the sum of b1 plus b2. So we're talking about, we're dividing by 2, we're multiplying by h, then we're adding b1 to b2, kind of in that order. So let's start doing the opposites. We want to get rid of the 1/2, so half of what the other, that's dividing by 2, so we can multiply both sides by 2. That leaves me with 2a, 2 times the area, is equal to the height times the b1 plus b2 in parentheses. Notice I'm not trying to transform anything, distribute anything, I'm just trying to undo. So the opposite of multiplying by h is to divide by h. So I divided by h. No, notice I didn't have to, this carries over the whole thing because that right there is multiplying all of that. Okay, and then I've only got adding a b1, so I got to subtract that, and then I just write my answer, 2a divided by h minus the b1 equals b2. The more you practice with these, the easier they will get, and it'll get simpler, but you got to practice. All right, so here's another one. This one's very similar to the linear equation one, because I want to solve for h. So I need to solve for this h right here. Okay, that's a horrible arrow, but you get the idea. So I'm going to treat this 2 pi r squared as a number, a singular number, and I'm going to move it to the other side. How do I move it to the other side? Well, it's being added, so let's subtract. So I'm going to subtract, move it over to the other side. Then let's look at all this. I want to solve for h, but all of that 2 times pi times r times h, all of that is multiplying h. So if all of that is multiplying h, I can treat it as like one number. Just like saying if I say 2 times 3 times 4, well, 2 times 3 times 4, that's 3 different numbers, but when you multiply it all together, 2 times 3 is 6, times 4 is 24. So I could treat it as 24 and then do something like that. Well, the same thing here. 2 is a number, pi is a number, r is a variable in place of a number. So treat them like all as numbers, and so let's divide. We divide, and we're done. Don't try to sometimes simplify these or go all crazy. I mean, there's going to be ways we'll learn about how to simplify, but right now I just want y'all to work with them and come up with the answers. All right, here's my last example. This is a perimeter formula. Oh no, he's brought back geometry. What is wrong with this teacher? Not, just kidding. So, anyways, we want to solve for L. Well, again, notice here we're adding 2w to this, so I'm going to subtract. And notice I'm always working the furthest away from the variable I want to solve for. So 2w is like the furthest away from the L, so I'm going to move that to the other side. Then I got to get rid of the 2 for the L, so it's 2 times L, so I divide. Notice I divided everything by 2, and this time I decided just to keep it under where everything's under 2, which is perfectly fine, perfectly legal, works easy, and there you go. So anyways, that's it for this one. Fairly simple, fairly easy, and you're good. That's it. Thank you so much for your time, and hope y'all have these notes when I see y'all. Thank you.